In this video, I'm going to talk to you about vector components. This is why it's good for us to have a good understanding of trigonometry, because without that, we'll be unable to resolve vectors into their constituent components. So, what I'm talking about when I refer to components of a vector is that any vector can be described as the sum, let's call our vector A here, it can be described as the sum of two other vectors that are at right angles to each other. So I'm going to call that AH for horizontal and AV. And what we can say is that A is equal to the sum of AH plus AV. When we have two vectors that we want to add together, for example, if we had another vector, let's call it B, we can also say that B will be equal to the sum of BH and BV then what we can say is if we wanted to add A and B together, so that would be something that would look like this. So that's A. B looks something like that. So if we wanted to add those two vectors together to get a resultant, then one way of doing that would be to find the sum of the vertical components and the sum of the horizontal components, which would give us a vertical component of the resultant and a horizontal component of the resultant. Then we'd be able to work out what the length of the resultant is and what its angle is. The best way to demonstrate that is through an example. So let's do an example where we're wanting to add a vector A, for example, that's at 30 degrees to the horizontal and that's 10 units long, to a vector that's at 30 degrees to the vertical, that's 7 units long. So what we're going to do is say, and we'll call that B. So we're going to say that the sum of A and B will be equal to the sum of the horizontal components of A and B, which will give us a horizontal vector, plus the sum of the vertical components of A and B, which will give us a vertical vector. So the horizontal components of A and B we can work out like this. A's horizontal component will be something like this, and B's horizontal component will be something like that. Now in the case of A, this side of this right angle triangle is the adjacent side. So remembering our trigonometry sentence, only hungry sharks attack healthy children on April Tuesday. So if we're looking for the adjacent side is equal to the hypotenuse times the cos of the angle. So for the horizontal components, we'll have AH will be equal to 10 times the cos of the angle. BH, in this case, is the opposite side of the triangle. So the opposite side is given by the hypotenuse times the sine of the angle. So it will be 7 times the sine of 30. And we can use our calculator then to evaluate those two expressions. 10 cos 30, and we get 8.66, 7 sine 30, and we get 3.5. So the horizontal component of our resultant vector, so that will be this one here, horizontal component of the resultant vector, will have a length of 8.66 plus 3.5. So AH plus BH will be 8.66 plus 3.5 will be 12.16 in length, and it will be horizontal, and it will be to the right, I should say. We're going to do exactly the same thing now with the vertical components. So the vertical components will be this vector here and this one here. Now if we define our sign conventions as up being positive and to the right as being positive and down and to the left as being negative, when we add these two vectors, the vertical component of the A vector and the vertical component of the B vector, you'll notice that this vector will be positive because it's an upwards vector, and this vector will be negative because it's a downwards vector. So when we add these two vectors, we'll be subtracting the vertical component of B from the vertical component of A. So let's do now our vertical components. Alright, so the vertical component of A is the opposite side of the triangle. So the opposite is equal to the hypotenuse times the sine of the angle. And the vertical side of the B vector is the adjacent side, so it'll be equal to the hypotenuse times the cos of the angle. Alright, and that will also be negative because it's in a downwards direction. So AV plus BV will be equal to 10 sine 30 which is 5 plus negative 7 cos of 30 is minus 6.06, and that'll give us negative 1.06. So what that means is the vertical component of our resultant is actually has a direction of downwards. So if we drew our resultant now, 12.16 horizontally, negative 1.06 vertically, it would look something like this. 12.16 vertically, horizontally, and 1.06 vertically. So our resultant really is something that will look a little bit like this. All that's left for us to do is find the angle and the length. Now this is a right angle triangle, so it does conform with Pythagoras' theorem. So the length of the hypotenuse will be given by the square root of a squared plus b squared. So that will be 1.06 on my calculator, square root 1.06 squared plus 12.16 squared. We get 12.21. So that's the length of our resultant, and to find the angle we can go back to trigonometry. If we know the adjacent and the opposite side, adjacent and the opposite, then we can say the tan of the angle is equal to opposite over adjacent. So here we'll say the tan of theta equals opposite 1.06 over adjacent 12.16. So theta then will be equal to the inverse tan of 1.06 over 12.16, which will be inverse tan 1.06 over 12.16. We get 4.98 degrees. Okay, so our angle is 4.98 degrees below the horizontal, and the length is 12.21 units. And that's how we use trigonometry to add two vectors.